Okay, so here's a quick video, well, hopefully quick, about just some of the ins and outs of instancing and using expressions to drive some instancing as well. I'm just going to use simple shapes here to do most of this. And the first thing we're going to start off with is how to derive, how to set up your instancing, right? And let's see here. So we'll just start off by creating an emitter. And this emitter will be a volume emitter, about yay big, and we'll have 0 speed here. So where's my, there it is, away from center and away from axis. So if we play that back, see that we get our falling particles, and I want these to just be frozen in space, so I'm going to go ahead and let me close this stuff up. I'm going to turn off forces, turn off collisions, and finally go down here, and I'm just going to make them a little bit bigger. All right, so first things first, let's get some instancing going on here. So we have, let's run this back. All right, so the standard way we would do it, set up instancing, is to pick our 3 objects, red, green, and blue, select our particle system, and go to end particles instancer. And if you go to the option box, you can see that, let's see, I call this shapes instancer, yeah. And you can set up a whole bunch of things here. I'm going to remove this. I don't know why it puts it in there. I'm just going to make sure that they're in the right order here, red, green, and blue. You can set all this stuff up if you have it already set up, but we don't, so I'm just going to go ahead and create that. And since everything is going to be set at 0, that's where we're going to get all these to red, right? Because our indexing is set to 0 already. So red is 0, and we have none of that. So we need to set up an instance index. And the way we do that is to go down here and add a dynamic attribute. Click on General, and we need to add our own variable that we can pass to the instancer and say, this is what defines it. So I'm just going to call it inst index pp because it's a per particle attribute. Each particle is going to have a unique or potentially unique number. And we're going to leave it as a float and per particle. Just make sure that those are all checked. And we can say, go ahead and add that. It doesn't matter what you name it. It just helps to name these things logically, because if you start adding more and more variables, then you have to remember which one is which. So once that's set up, we can come down here in our particles instancer tab, and we can just go down and assign our object index to our inst index, which should show up in that menu. All right. If your variable did not show up in here, there's 2 reasons. One, Maya just needs a little refresh, and you just have to select your particles again, and it could show up. Or you want to check and make sure it didn't come down here into extra attributes, because if it did, that means that you've it's here, but it doesn't have a little dialog box or a little text field. If it shows up down there with a text field, then you didn't make it a per particle attribute, so you can repair that. All right, so here we are. We have this, and I'm going to create an expression that launches when the particle is created. So we're going to right-click on here, choose Creation Expression, and we're going to write in a handy instancing thing, right? So we can say inst index pp, which is what we want to control. Let me make this bigger. And we're going to say equals, and what we would normally think is it's a number between 0 and 2, 0, 1, 2. So we could say rand 0 to 2. Now you would think that that would give us the correct value, but it won't. It will only give us random numbers between 0 and potentially 2. So the chances of us actually hitting 2 is actually pretty small. So we really want to say 2.99. But this is asking for an integer number, not a float. And we want to be a little bit more controlled than this, so we're just going to say floor, which rounds any number down, including 2.99. So now we have an equal chance of getting from 0 to 0.99, and 1 to 1.99, and 2 to 2.99. So that gives us the proper distribution. So we'll say create and get a couple of changes here. We're going to close it and we're going to run back and hit play, right? And this looks like we're getting what we want, right? Because then the way to check it is to go up into Windows, General Editors, Component Editor, and it gives us this whole big component spreadsheet. And if we right-click, we can choose Particle, and I can select this one, go to Particles, and I can see that my inst index is 0, which is our red one. I'll come over here to the toruses, which is blue, and I'm sorry, the torus is blue, yeah, so that's 2, and cone should be green, so that's 1. All right, so everything is working out Jim Dandy, right? And you can select a bunch of these at once and check and make sure you've got a nice distribution of stuff. All right, so coming back to this, that's pretty handy, right? But what if we wanted to be a little bit more picky about this, right? Right now, each object has its own potential chance of being some value. So there's a couple ways of doing it. Like we have an equal chance of being any one of these. But what if we really just wanted more spheres than anything else? So we can come back to this expression. And the way that we want to do this is we have to first create a value that we can compare things against. And we can create this value and destroy it. So, because we don't need it all the time, we just need it every time we want to make a decision. And I'll show you what I mean here. So let's comment that out so that doesn't operate anymore. And I'll come down here and I'm going to, create a new floating point number. And we're going to call it randval, just because that's what it's going to be, a random value somewhere between, say 0 and 100. Okay, so now I've got this random value in here. So how do we choose which index we want to put it in? Well, we can use our handy dandy if statement. We can basically say if randval is less than 80, right, our greatest value first, then our inst index, and I'm sorry, let me make this bigger for you, our inst index pp will then equal 0, right? So that's an 80% chance, essentially, that we're going to get a red sphere, all right? And then we could say else if randval is less than, well, what's remaining here, say 90, then inst index pp equals 1. And then if nothing else is left, else inst index pp equals 3, right? So now if we get a value and the first check we do is it less than 80, well, if it's not less than 80, then if it's greater than 80, then we go to the next one. Well, then if it's not greater than, if it's still greater than 90, we go to the next one. And then that's our final option. But this basically says that we have an 80% chance of getting a red sphere. We have a 10% chance of getting a green cone, because that's the difference between these two numbers. And then we have the remaining 10% left for the blue torus. So let's say OK and close, and let's see if we get that sort of weighting. So we definitely have a lot of red in here, and we're getting a lot of blue, but not so much green. Let's see if I made a mistake in my creation expression here. Randval. Ah, there it is. 1 and 2. I wasn't indexing my things at 0. So 0, 1, and 2, right? So let's edit that, and now we should see, there we go. So 80% red, 10% green, 10% blue. And we can go through and we can make those alterations as much as we want. Maybe we just wanted 10% of this to be red, and then the next, say, 50%, which would make this 60, would be green, and then the remaining 40% would be blue. So we can try that out. And we can see that. So that's another way to do it, right? So we get a different distribution than what we want. All right, so that is pretty slick. But maybe there's yet another way, a way that is actually far more intuitive than this, right? Because we like to be visual people, right? So let's wind this back. And I'm going to start by hiding my instance there, right? So if I just hide that and I play it, we'll just see our particles pop up. Now, within particles, we have this really kind of delightful way of adding color down here, which is just pretty easy. We just change out our color. But it doesn't give us easy access to this color. Not quite as easy as, or flexible as using this dynamic attribute color here. But if we add that, let's see what happens. So if I click here and I say add per particle attribute, add, I just get this RGBPP and my particles will remain white, which isn't helpful at all. So what we want to do is be able to pick a color. Now I have this nice thing where I can create a ramp, and I would like to choose a color from a ramp, but how do I choose, whoops, let me break that connection there. Come on now. But how do I choose, I can't seem to click on anything. There we go, break connection. There we go. So how do I choose a value along the ramp in order to choose a color? For example, if I make a ramp in here, 2D textures, create ramp, and let's find that guy. You see that I have this out UV, and it goes into my UV coordinates, and it's going to feed the values into here, and my ramp is based on the V value, right? So how do I get that value to drive my choice along here? I'll show you. So we're going to come back here. We're going to create a new, I'll give you the hint, which is we'll look here and say create ramp, and we'll click this, and we'll see that input V right now is particles age. So as these particles get older, they change color. But I wonder, there's got to be a way to add a new thing in here, right? Which is pretty straightforward. Just like we did before, like the inst index, we're going to say general, and we're going to say rand color. Right? And it's just going to be pp. And we'll say float per particle and say OK. And then we go to rand color, and we find our index here. So we're going to actually do this first. So let's give myself some space here. We'll say rand color pp equals rand 0 to 1, right? We want a value between 0 and 1. And you can call this anything you want. You can call it Brad or Greg or Jane, whatever you want to call it. So say edit and close. Now, if I play back, still nothing, right? So what we want to do now is come back to our RGBPP, right click, say create ramp, and make sure you choose this option box. And in here, we're creating a value for each particle between 0 and 1, and it's called rand color pp. Say OK. OK. Nothing happened. That is all right. If I play it back, it looks like this. And that is because right click, edit ramp, it's black and white. So what we can do now is turn our ramp into a color ramp. So red, green, and blue. There we go. And if I step forward, you'll see that it now reassigns all those colors based on where it's landing in the ramp. For example, this particle right here is close to here. It has a rand color pp value of close to 1. And this one is close to 0.5. And this one is close to 0. So what if we choose to do a different kind of ramp? I'm going to choose no interpolation, and I can do this now. All right, so now we can just choose 3 primary colors. Step forward. right? No in-betweens anymore. It doesn't matter where it lands, it's just up here. So this is good, right? And if you notice, we can change these to different proportions and step forward, and we get different values. So that leads us to think that maybe our indexer can use these. So let's head over to the indexer, right-click, and go to our creation expression. And instead of rand value, I'm just going to go ahead and see. I can get rid of these for this particular expression. We don't need rand value anymore, but we do need to access the RGBPP. And to do that, we have to kind of place it. This is a kind of annoying thing, but we're going to place it into our own vector here. Actually, you know what we can do? Yeah, it's just good practice to do this. Vector, we'll just call it CR for color. And we'll say CR equals RGBPP. All right, notice we have that $sign. We're calling it a vector, so it knows, and it's getting the value from RGBPP. So now we can say if $CR equals two equals there, 1, 0, 0, and our double angles for our vector, so this is red. So if it equals that, we get 0. And if we equal, copy and paste wherever we can, this, we get this, and if it equals anything else, we get 2, right? So if it's 1, if it's red, it goes to 0. If it's green, it goes to 1. If it's anything else, probably blue, it goes to 2. And we hit edit there. So now our inst-indexed PP is getting its particular value from the RGBPP, which is driven by this number, right? So as soon as you create this number, RGBPP changes. So after this, we can do this, and then we can use that value to drive our instancer, right? So let's close that and see how that worked. And remember, I already have my instancer set up as red, green, and blue, and in the particle, we already have the instancer set up to inst-index. So we haven't really changed much. But if I unhide it, you can see that if we look on the bottom, let's run it back. Oh boy, not good, Jeremy, not good. Maybe I do need, what have I done? Doesn't look like we're holding on to this value. Is that value changing? Actually, make sure I have a white particle over here, which is very strange. There, it's changing to red. So it is not happening at the right time. So let's check it out here. So we go to inst-indexed creation expression, creates this value. We get our RGBPP value, and we feed it into our chooser, red, green, and blue. And running it many times does not change it to be right. Let's check our array mapper here. Let's check and see. Oops. Let's check and see our ramp. See if it does anything proper here. More green than blue. It seems to actually be working. Maybe let's get rid of our lifespan. Let's change our lifespan to live forever and play back. So, even though it's lying to us about our colors, it is definitely working, right? Bring up the red a little bit. Well, there it is. And if I change this and step, change this and step, it's only going to be real time. Well, all right. So I think what the problem is that we get a color alteration after the first frame of existence. So let's move this expression out of creation, exit. I'm going to cut that and into runtime before. And then I'll paste that. All right. So now that's working. Okay, so basically what was happening is we were getting a color choice, and before that color choice could be enacted, the instancer couldn't grab that value. All right, which is fine. Actually, what's more interesting about this is if I now go to my ramp, right, I can actually change this and step forward, and it can change dynamically. Now, the reason this works, all right, so let's go with this, because this is more interesting anyway. The reason this works is because our rand color here, our creation expression just creates a value that will choose our color from that ramp. And in between this creation and the next frame of execution, that color gets chosen. So in our runtime, now this happens every frame, we check the color, and then we make our choice based on that. What makes this sort of interesting to play with is that this color, because this happens every frame, that means that we can go and change that color, and it will reevaluate everything. Right? So I can bring this way down and add a lot of blue and just touch forward, and you can see that that change is instantaneous. And then if you find something that's working for you, you can certainly set initial states, or you kind of know what you're going to be working with here in the future, right? So there's some little odd popping, but this is an interesting situation. Anyway, it's just something for you to work with here. One more time, lots of green. One more time, frame forward, lots of red. Okay, so one last thing to look at. Thank you for sticking with me. I'm going to get rid of everything except my primary shapes. This is going to be similar, but perhaps as useful or more useful. I will create a plane, and we're going to do one more round of instancing, and we're going to use color, so everything should be pretty familiar from last time. This one will be a little different because we can do it all in the creation expression. So we're going to start with this plane, and we're going to add an emitter from this object. And we're going to go through, and it's going to be 0 speed, surface emission, which is important, and maybe at a little bit higher rate here. Something, I don't know, just make it up 400, or maybe, yeah, that's fine. Create. All right, so if we let that play, again, we have these particles. I don't want them to fall, so I'm going to set them to no forces. I'm going to get rid of collisions. Going to make the points a little larger, and we're going to run it back and play it again. All right, so this looks good. You'll probably understand where I'm going to come from here real quick, but for this plane, let's just create a new material. Let's say assign new material. I will choose a boring Lambert, and here in color, I'm going to choose a ramp. And I could choose anything I wanted to here. Let me change to textures. Oops. All right, there we go. In this case, I'm going to choose a ramp, but I'm going to set it up just the way we had before, with red, green, and blue. Okay, and I'm going to set this to no interpolation, so I know. And I'm going to do this. And I'm going to take this ramp, and I'm going to bring it up here in the hypershade under, it's under my textures. I have this ramp right here. and I'm going to roll down to inherit color, and I'm going to drag this onto there, right? Now I did get a warning, and that warning is telling me that my particles need that RGB PP value. So I'm going to go ahead and run over there real quick and create it. Color, RGB PP, add it, wind it back, and run it. All right, so now we see that we're getting, it's hard to see, there we go. We're getting those particles spanning the colors. And once again, how do we drive our instancer? We go to General. We need our index. We need an index variable. So inst index pp. It's got to be a float per particle. Okay. And now what's interesting about this is that the color is being added to the particle before it's being created. So so now we can do what I was trying to do before, which is to create a creation expression here. And I'm just going to, I have it over here, so I'm just going to copy and paste it because it's the same version we used before. So under creation, we just move the RGB PP value to chooser, or whatever you want to call it, and then we just check to see if it's red, if it's green, or if it's blue, or if it's something else rather. And it's safe to just say something else. That way it always has something to choose. And then we have 0, 1, and 2, and we're going to say create. And you know what I've forgotten to do is actually create an instancer. So so we can say red, green, and blue. And these are moved off origin, but they do have their zeroed values, so they'll go from their 0th value. So we'll say create instancer. Oops, we need a particle system. Get rid of the plain. Red, green, blue, particle. Particles, create instancer, and it's all red. And that is only because we haven't given it down here. Our index needs to be inst-indexed. And there we have our particles being created. So this is obviously useful, right? Hopefully, because what I could do is I can change this ramp to anything I want it to be. It doesn't have to be this. It can certainly be a circular ramp, right? Where I have something encircling something else, and there's a lot of noise in it, which is cool. It's a higher frequency noise, which is certainly cool. And we can run it back, and we can play it. And it's going to behave that way, right? And better than that, we can actually get rid of this texture on the surface because it is independent of the surface texture. The emission texture comes from the ramp as we feed it, and it doesn't have to be on the surface. So if I wind it back and play it, you'll see that we're basically creating that texture again. And this is what's really useful about this, is that if we've this doesn't have to be coming from a ramp at all. We could bring this in as a file texture. We could be using noise. We could use anything we wanted to. It just helps a lot to use these RGB values because it's very clear. And yeah, there's only 3 options here, but there's nothing stopping us from adding many colors and having many different options, or using many colors, and in our expression here, instead of saying if it's red, make it 0, there's nothing stopping us from saying if it's red, do a floor rand 0 to, I don't know, 5.99. In which case, we could choose between all of them. Or we can just do that here by saying, if it's red, we can choose all of them. If it's blue, if it's green, we can just choose green. And if it's red, if it's blue, we can just choose blue. So we can actually stack up a whole bunch of objects or different expressions inside of here, right? Because now in the red zone, it can be a mix, but we have purity on the outsides. So this is a really interesting and powerful technique, allowing you to do anything you want. And certainly, you can explore a lot of different options within here, but I would say some ramps and certainly file textures are going to be your best way to go. And it will allow you to do any kind of thing, pathways through grassy areas and little forests, or anything you really want. You need big rocks here and little rocks here and no rocks over here. Well, just change these out and you can repaint a new map and relay things out, and that works for you. So I hope that helps. It's kind of an odd little tutorial. I'm sorry for the mistake in the middle, but we learned something. So good luck with everything, and happy instancing.